Okay, so in our third installment of the vertebrates, we're going to move out of the water and onto land. But before we do that, we got to look at those organisms that were experimenting with that sort of jump between land, and that's what we're going to talk about. And that's what we're going to talk about in tetrapod evolution. Land-dwelling critters, or tetrapods, those with four legs, evolved from a lobe-finned fish, and some of this data is relatively new. Back in 2006, a fossil was found of an organism known as Tiktaalik. That's Tiktaalik on the right-hand side, which was a lobe-finned fish that lived about 12 million years before the tetrapods. Now, while Tiktaalik was a fish, these lobe fins allowed it to pull itself out of water. Maybe if the oxygen levels in the water began to drop and Tiktaalik had an ability like the lungfish to breathe atmospheric air, that would have helped. We talked about acceptations, about what good is part of a leg. Well, this is not a complete leg, but there would be an advantage here if Tiktaalik began to feed on things that ran up and down the shore, right? Or again, held its head out of water on a log or a stick if the water was getting... water, when it gets really warm, loses oxygen. It doesn't carry as much oxygen. So fish sometimes can get oxygen starved. And so maybe this fish found a way to breathe some atmospheric oxygen and used its lobe fins to crawl out and do that, right? Well, you know, we're jumping quite a bit ahead, but if we take this idea of these lobe-finned animals and keep working with that and living near the water, we can easily make the jump over to the bottom one, which are Ichthyostega. These were some of the first amphibians. They had very sturdy legs, but the hind limbs still were not completely developed. They probably moved like a seal. But one of the things they did have, which helped them out on land, was very strong, broad ribs, which helped them protect the lungs and the heart. But they were buccal breathers, too. Buccal means they would gulp it in their mouth and force it down into their lungs. So it's like swallowing air. And in the background, even though the resolution isn't so good, it's kind of the environment that we're talking about. There's a lot of swampy areas around during this time. So when we moved out on the land, some of the vertebrate land adaptations were legs that we talked about, lungs. Gills are more efficient, but you can't use them in air. There's an ichthyostegan, or an early amphibian, is kind of holding their head out of water. A circulatory system for large muscles. Now we're going to have two circuits and a more chambered heart. So we're going to run blood through an oxygenation circuit like the lungs or wherever, and then back through the body. The reproduction is going to occur with the eggs down below with the little black dots. Those are amphibian eggs. They're anamniotic. So these eggs must be laid in water. And of course, one of the biggest problems moving on the land is going to be that desiccation issue. There's a little not time lapse, but you can see the lobe-finned fish, the early amphibian, and I've stuck the Tiktaalik in between. You can see the gradual change and the building up that's occurring on the appendages, even though that poor amphibian there doesn't look very happy, does he? So then we have the amphibians. These were the first vertebrates to walk on land. About at the end of the Devonian, this is when the fish were going extinct and a lot of other environments were opening up. There were a lot of marshes, very wet and warm back then, so there were a lot of terrestrial arthropods, a lot of things for amphibians to eat. Of course, we talked about legs, and that was helpful, except in the Sicilians, which had a burrowing lifestyle. That's the Sicilian there on the right. Looks like a segmented worm, but it is an amphibian, although we do think that Sicilian ancestors had legs. They lost them. Like snakes, same thing. Snakes had legs and then lost them. Some of these breathe with cutaneous respiration, which supplements their lungs. Now, this is what we mean by a two-circuit. If you look on the right, amphibians have a two-circuit circulatory system. The blood goes through the capillaries, which could be in the skin or in the lungs or wherever they're breathing, and it gets oxygenated. But the heart is different, you notice. It's a three-chambered heart. So what happens in this is in the ventricle, the blood gets mixed. And so the blood that's in the purple is a mixture of oxygenated and deoxygenated. Now, is that ideal? Well, no, but it works for these critters, right? And that's all you got to do is work well enough for these critters for it to work. Now, the problem is you're going to have some limitations. You're going to have to stay kind of small. You're going to have a relatively low metabolic rate. So you're going to live a relatively low-key life if you're going to have a mixed blood sort of respiratory or circulatory system, but indeed it does work. And some of the different groups of amphibians are the ones without the tails, although they had them one time. These are the tadpoles, the frogs. Frogs and toads differ by their skin. Frogs usually have smooth, moist skin, and toads have wartier skin. Frogs are usually long jumpers, and toads are hoppers, and toads tend to live in the drier climates too. Reproduction down below is what we call amplexus, so that's a mated pair, and those are the egg mass that's being formed. So it's an anamniotic egg. It doesn't have any water-type membrane, so it's got to be laid in water. These animals engage in external fertilization. And again, they lose their tails as they grow and they metamorphose. There are a few species. There's one species in the lower right that as an adult has a tail, but for the most part, these animals are anura, without a tail. The caudata are the salamanders. They have tails, long bodies with tails, smooth, moist skin, which helps them respire. We have internal fertilization. What it is a little sperm packet that the male presents to the female. And that little picture there with the finger is a sperm packet. The larvae are similar to adults, so this is what we would say simple development. These salamanders, newts, and sirens, some of the world's largest amphibians. There's one down below that the guy's measuring out. There's a siren in that net in the lower right. And sometimes these animals have gills, at least at some parts of their life. You can see that one down below. I just think that's a cool picture, that one up above walking. The Apoda, which is not a well-known group, these are Sicilians. There's the ancestor of the Sicilians with the legs, right? This is very, very unique organism. Reproduction is internal with maternal investment. The larvae, see the little marbles there on the right? The larvae actually eat the mother's skin. The mother provides skin as a form of maternal investment. Very weird group. Very interesting, serious-looking mouse.